there are very common examples, and if we look here at an example, we can look at a positive, or I'm sorry, a negative feedback loop. And the example that we're giving here is for body temperature, right? So you can see here that we have all of our kind of same events that we were talking about earlier. So you have a stimulus, you have a sensor, receptor, you have the control center, you have the effector, the target effector, and then you have the response that's going to bring about the change, right? So you can see here in an example of body temperature, you can see each of these five main components with this example, right? So you have a stimulus. You have something that causes your body temperature to exceed 37 degrees Celsius or so, 98.6 degrees Fahrenheit. Maybe you're exercising. Okay, maybe you are running outside. It's in the summer, and you begin to have an increased body temperature. Maybe you're an athlete and you're playing a sport, and you're running up and down the soccer field. You are running up and down the basketball court. You're doing something that's causing your internal body temperature to increase, right? That increase in temperature is detected by receptors in the skin and in the brain. So think there are thermoreceptors in the skin that are detecting this increase in body temperature deep in the body. This is going to send a signal to the control center. So this temperature regulatory center in the brain. This is referred to as the hypothalamus, which is, think of it as like our body's internal thermostat, if you will. This control center is then going to initiate a signal. It's going to give an output signal. So this red arrow that you see here, this is indicating the output signal, right? Going to the effector. And the effector, when you think of an effector in the context of negative feedback loops, think of the effector as the thing that is going to bring about the change, right? So think whatever that initial stimulus was, the effector is going to bring about a change that does the exact opposite, right? So meaning if our initial stimulus in this case was an increased body temperature, right? So we have an increased body temperature. Whatever our effector is going to do is going to be something that is going to decrease body temperature, or it's going to initiate some response by the effector to bring about the opposite. So in this case, a decreased body temperature. So in this case, it's going to be sweat glands, right? We're going to begin producing sweat, right? A type of exocrine secretion. So sweat glands in the skin. You may also have vasodilation, so you bring more blood flow to the skin to begin to dissipate more heat, right? So you'll notice if you work out, if you exercise, if you're an athlete, this is especially true in the summer if you're doing so outside, but you'll notice that the vasculature, maybe in your hands and your arms, will be very dilated, right? You'll have lots of blood flow to the skin, and this is in an attempt to dissipate some of that excess heat. Again, in an attempt to increase the amount of heat that we're losing, which again is going to decrease our body temperature, right? So one important trend, or one thing that you'll see for negative feedback, is it's always the response, right? Our response here is always going to be the opposite of our initial stimulus, right? So in this case, increased heat loss, so decreased body temperature, that's the opposite of what our initial stimulus was, which was increased body temperature. Okay, so there's always going to be the opposite effect, if you will, whenever you're talking about negative feedback. Okay, you could apply this to other examples: blood sugar, heart rate, blood pressure. You could apply this to many different examples, but you're going to have the same events. You're going to have a stimulus, you're going to have a receptor, you're going to have a control center, you're always going to have an effector that brings about the change, and then you're going to have the response itself, which again is going to be the opposite of what the initial stimulus was, right? So stay around for part 2, and in part 2 we're going to talk about positive feedback loops.